This conference will now be recorded.
All right, so in one word, if I have to explain you what these programs are, interface is like a rule. Okay, it's like a rule or agreement program. Okay, concrete class is a program that has complied to all the rules in interface. And abstract class, it's a program that is incomplete and does not comply to all the rules. Okay, this is a rule or agreement program. This is a program that fulfilled this agreement. Abstract class did not fulfill this agreement, in short words. Okay, so let's see how we will use this. Okay, so before we do subclass, let's have a quick look at interface. Okay, right, so we have to do subclass. Polymorphism, we'll do it later when we have the polymorphism chapter. Final we'll do later. Okay, interface. Okay, all right. Now when I say rule or agreement, think about this, right? When you're planning something, okay, you start with a rough note, right? What is your to-do list? Right, I need a job, I will buy a house, okay, I'll buy a car. These are to-do list. Okay, but have you already done that when you're writing the to-do list? It is just a target or a goal, isn't it?
Yeah, just a plan. Yeah.
Okay, it's just a plan, it's a target, it's a goal that you want to achieve. Okay, it's a rule, it's an agreement. Okay, so that's what interface are. Interface is the very first program that you write when you begin working on a software. Okay, it will not have any code or any program in that. All it will have is the set of methods that you are hoping you will end up writing one day. Okay, it's like a to-do list. Okay, so when you begin writing a software for online shopping website, you start with some ground rules. Okay, what are the things, what are the must-have features in your software? Okay, so you start out writing like this. Okay, so your shopping website requires, let's say, a login. Okay, so remember one thing, interface does not have the code. Where do we write the code for a method?
The main method.
Where do you write the code, the logic for a method?
In class.
In class.
Of course, everything is in class. I'm asking for
Inside the
this
method.
method. If I have to write the program, the logic for this method, where would I write it?
Inside the block.
Inside the method block, inside the curly block. This is where you write the code on how to check login. This is what you do, right? So this is what we call method body. What do we call this as?
Block.
Method block.
Method declaration or signature.
Method signature or method declaration. Guys, don't make me repeat that. I gave you all the things in the beginning. You need to know what each and every lines are. Okay, I told you this is a line, this is a part that we call method declaration or method signature. Please don't make me repeat that. All right, so in an interface, all you have is a method declaration or method signature. You will not have method body. You will not have the code. You will not have the logic. No implementation. This is just a wish list, a to-do list. You will not do anything. Okay. Okay, so when you set out writing the software, this is what you do. Okay, you make a list of all the things that you want. Okay, so you know that what is your target? What are the things you need to work on? Okay, so this is like a checklist, to-do list, or a target or a goal for your assignment, for your task. Okay, so anytime someone begins writing a project, this is what they do. Okay, so these interface are technically provided by the lead, the technical senior technical developer or the technical manager. Those people usually come up with this interface and give it to you. It's your job to write the code for this interface. Okay, so just to make sure you guys are on target. Okay, so just to make sure that you guys know what need to be worked on. Okay, technical managers or leads, they usually provide you this kind of a program, okay, which doesn't have any code. You are the developer, you will write the code for it, you will write the logic for it. Okay, just to make sure you're on track and you're focused on whatever task has been assigned to you, they give you a list of interface methods in an interface like this. Okay, now this program will become an agreement between your manager and you. Okay, and you have to comply to all the rules that are set forward in this program, meaning you're supposed to write the code for every single methods written in this program. Okay, so think about this program as a rules or an agreement or a plan on what your software should have. Okay, now here is the thing. This program will act like a virtual digital police. Okay, if you don't follow these rules, your program will not be executed. If you do not follow these rules, if you do not write the code for each and every one of these methods, your program will not execute. You will get an error. Okay, so think about this like a virtual digital police kind of thing. It makes sure you comply to all these rules. Okay, so first thing, interface programs are like a rule or agreement. Okay, these are the rules to write a shopping software. If you need to come up with a shopping software, these are the rules you need to follow. The rules are: every shopping website has a login page. Every shopping website has browsing features. Every shopping website has a checkout. If any of the website has just login, would you call that as a shopping website? Just a login page?
No.
Is that a complete shopping website?
No.
No.
It's an incomplete shopping website, right?
Yes.
In other words, that's what we call abstract. Okay, abstract means incomplete. Okay, abstract is incomplete. Okay, so if you find a login page, just a website with just a login page, you'd call that as an abstract shopping page. It is not a concrete or a complete shopping page website. What it is, it's an abstract shopping website. Okay, it's not a complete one. Now these are the rules that every system has to follow in order to declare themselves as a complete system. Okay. Now this rule applies everywhere. Think about what are the rules for if you are planning to manufacture your own vehicle. Okay, so what are the rules for anything to be called as a car? What are the main features in a car system?
Accelerate, brake.
You start, you stop, you accelerate, you take turns, you reverse. Okay, these are the basic features. So what we do is we set some rules. Okay, we set some rules like this. Okay, so this is the rule for a car interface, meaning if anyone ever plans to launch a car which people could buy, they have to comply to these rules. Okay, if someone tries to sell you a car which can be started but cannot be stopped, would you buy that car?
No.
You won't. So is that a complete car?
No.
It's an incomplete car. It's an abstract car. It doesn't have all the things that we need. Okay, so interface enforces people to follow these rules. Okay, if someone tries to write a car, they will have error. Someone tries to write a software to write a car, they will get an error. Okay, so this is like a virtual police which will keep every developer in check, focused on the goal. Okay, so that's the only purpose of this program is that. Okay, so before you set out doing some big things, you sketch out the plan. Okay, if you want to be a millionaire, it won't happen overnight. First you need a entry-level decent job. Okay, then you will invent something, or maybe you'll take a promotion. 10 years down the line, you'll have enough money to become a millionaire. There is a plan, right? Without that plan, you wouldn't have anything. So think about interface like a plan. Okay, this is my vision, this is my goal. Okay, once these goals are set forward to you, your job is to start writing the code for one by one. Until you reach that milestone, you won't get a complete system. Okay, every single rule has to be followed. So first, do you understand why we need an interface program?
Yes, sir.
Yes.
Now let's see how this program forces developers to be in line. How does this virtual police, okay, keeps all the developers in line? Okay, now there is a slight difference if you noticed. What are the differences with this and a class and a normal class?
Don't have a code.
Very good. There is no code. This is just a plan. Just because you made a note, to-do list, I want to be millionaire, you won't become immediately as soon as you write it down. Okay, it is just a to-do list. Yes, there is no code. What else?
We write the name keyword. We use a keyword interface.
Yes. Rather than writing class, we call it interface. Okay. Anything else?
No return type.
Okay. What's the return type?
Like, is this a plan? So I don't think we're returning anything from the interface.
That will be inside the method body, method code. There is no method code, so how can there be a return type? No method body, no return type.
Okay.
But that's not what you call return type. That is the return statement, guys. Again, go back to the day I gave you all the terms. You have to remember the right words. Return type is what we call this part. What you're referring to is this one. What do we call this line? Do we call this return type?
Return statement.
Yes, we call it return statement. This is the line we call return statement. Return type means this. Okay. Like I said, you have to have technical conversation all the time. Only then things will be clear. Okay. All right. So anything else is missing or different than a traditional class?
I think it doesn't have any data or variables.
Very good. Very good. There is no variable declared here. Now tell me one thing. What's the connection between a variable and a method?
We use the variable in the method.
A variable changes, but the method does not.
Variables are used for dash information.
Storing
Fill up the
info.
blank.
Storing the information. To pass information.
Store information.
To store information. And methods do dash information.
Process the information.
Manipulate.
Use data.
Manipulate, use, change. Okay. Now in the methods, how do we change value information?
You assign it.
By assigning the value.
By assigning the values. But don't you need a method body to do that?
Yeah.
Yes.
You do it here, right? You don't do assignment in the method declaration, right? This is the only thing you have. In the method body is where you change the value. Here, you store information. And in the method body, you can manipulate this information. You can print it, sys out, or you can change it from 1 to 123, right? Now here is the main difference. If you do not have method body, how can you change the values? So is there any point to have a variable if there is no way to read it or change it?
No.
That's why most of the time you will not find any variables here. Interface are typically written only with methods, that to just declaration. Okay, interface has just method declaration. They typically don't have any variables. The reason is, if the methods do not have method body, then what is the point of having a variable? The whole point of this two DO is this guy will store information and this guy will manipulate that information. They will read it, they will change it, update, delete. That's the whole relation of variable and method. If interface doesn't allow you to have method body itself, then you cannot change that value, isn't it?
Yes.
No method body, no lines to change the code either. And that's why nobody writes any variable. It doesn't mean you cannot write it. You can still write it. Okay. But if you write a variable here, this is what we call as final, meaning this value will not be changed. You cannot change this value because interface do not have method body. So there is no point in allowing anyone to change the value either. Okay. So that's the reason people don't write variables in an interface. Okay. Now, as a thumb rule, it's a good practice to write a name that starts with an I. Okay. if you write the name with an I, this indicates that this particular program is a interface. Okay, it is just a naming convention, just like how we write the method class names. The first letter of every word should be capitalized. The first word of the second word onwards should be capitalized for variables. These are just standard naming convention. Okay, so similarly, when you're writing interface, you have to make sure that you start the name with a capital I. It is just a good coding practice. If you do not write capital I, your program will not fail. Okay, your program will still work if you do not write I. It is just a good coding habit. Okay. All right, so this is how you write a interface. Okay, the keyword is interface rather than class. Okay, all your methods have just declaration. Okay, all your methods have just declaration. There is no code for it. Okay, so if I'm your technical manager, okay, and we work on vehicle company software. Okay, so what I do is I give you this interface. Okay, this is a program I give you, and I tell you I want you to complete this software. These are your tasks. Okay, you need to write the program for start operation, for stop, for drive, and turn. Okay, so this is like an assignment or a work or a task that I hand it to you. Okay, by doing that, there won't be any verbal miscommunication. Okay, this is a written agreement between me and you. If you do not comply to all these rules, your program will never succeed. Okay, so this is what we do. You as a developer will start writing the code. Okay, so let's say you have a vehicle. Okay, so this is your program, public class. Okay, now if you take the responsibility of writing the code for this interface, this is how you do it. You start with implements. So do you guys know what an implement is? The general term of implement?
I think, is
General
it
term.
written?
It's a tool.
Right. Okay, implement is like actually working on it. Okay, actually writing, actually making it work. So when you take the responsibility of writing the code for this interface, this is the keyword you use, implements. Honda implements iVehicle. Okay, now if you are the developer and you took the responsibility of writing this software, okay, these were just a wish list, to-do list, target, goal, task, assignment, rules, agreement, whatever you call it. So these are the rules that I give you. These are the agreement that I give you. Okay, this is what you need to comply with. This is what you need to deliver. Okay, then you start writing the code in a real program. Okay, public class Honda implements iVehicle. Now, have you written all the code that is mandatory?
No.
Not yet.
Has your program defined every single method that I have written here?
No.
No. And that's why it is causing you an error here. It says the type Honda must implement all the inherited method stop. Okay, now let's do one by one. Okay, let's say you start working on the first method. All right, so you wrote the first method. Okay, you wrote the code for first method. Does that mean your assignment is done?
No.
No.
Not yet. And that's why the error still persists. Still, this error doesn't go quietly. Nothing yet. All right, so now you can relax. So did your program at any point relax? Did your program anytime stay quietly until you did all your tasks? Did the error go away until you finished all your assignment?
Yes.
No.
Right? That's what interface is. Interface enforces rule on the program. Okay, interface enforces rules on the program. Okay, so until you finish all your task that is given to you, that error won't go away. Okay, that's the benefit of having interface. It will keep you as a developer focused on the goal. You can never say that I didn't get this information. I didn't know I had to write the stop operation. You can never argue, you cannot deny that you never knew or you forgot or you were mistaken that a car does not need a stop function. You can never say that because you were bound to an agreement here. Okay, so this part is what forced you or kept you in check. When you say implements iVehicle, you or this program took the responsibility of implementing every single method listed here. Okay, now other than this, you can have your own method. Having more doesn't matter. Okay, you can have your own method. You can have as many additional methods as you want. More the better, but the minimum that we need is these four. Okay, and here you can have variables. Fine. Okay, here you can declare variables. You can also declare variable here, but I will tell you in detail about this variable in the chapter final. Okay, for now just remember final means you cannot change the value. Okay, see, you cannot, it's final. Okay, if you initialize a variable with one value in the beginning, you can never assign a new value to that. That's what final means. Final means, as the name goes, it is final. No more changes. That's it. Okay, if you declare a variable here in the interface, the downside is you can never change that value. If you declare it in a class, yes, you can change it as many times as you want. No errors. But this will cause the error. Okay, that's what you need to remember. We'll go in detail what final is in our final chapter. Okay, but for now, remember, if you declare something here as a variable, you cannot change it. All right, so this is what we call concrete class. Okay, concrete class means the program that has complied to all the rules in the interface. Okay, so what were the rules in this interface?
All the methods, method declaration.
Four methods. These were the rules. Okay, you need to work if you want to start your own company, a vehicle company. Your model should be able to start, stop, drive, and turn. That was the rule. Did you comply to all the mandatory rules? Yes?
Yes.
So if you comply to all the mandatory rules, this is what we call concrete class. Concrete or complete. Okay, this is what we call as concrete or complete class. If you forget to do any one of these, this error won't go away. Okay, to fix that, you can declare this as abstract. Okay, meaning we accept this is not a complete program. We accept that this is not a complete program because one of the method is missing, isn't it? The turn method is missing. So what we need to do is we have to declare that this is not a complete program. This is an incomplete program or abstract program. You have to specifically tell that. Okay, so that's the three categories: interface, a concrete class, and an abstract class. Interface sets rules. Concrete class implements all the rules, writes the code for all the rules, and abstract class basically is an incomplete program. It's incomplete because as per the rules provided by iVehicle, there should be 4 mandatory operations, but you don't have all the 4 of them. That's why we'll declare this class as abstract or incomplete. If you do not comply to the rules, your program is incomplete or abstract. If you comply to all the rules, your program is complete or concrete. So does these 3 terms make sense?
Yeah.
Yes.
Now let's take a deep dive. Now the entire signature should match. Okay, if your program is called, if your method is public void start, no parameter, you should have public void start, no parameter. If you write int a, okay, so this is a complete program: start, stop, drive, turn. Start, stop, drive, turn. If you have public void start here, your method signature should also be public void start here. Okay, if you change the definition, are you really complying to this? Is this method implemented here? What did the iVehicle say? No return types, no parameters, isn't it?
Yes.
So does your program has no return type, no parameter?
It has the parameter and the return type.
It has parameter, it doesn't have return type, void. Okay, and that's why this error. Because this, just because you have the same name doesn't mean you did the job. You should have exactly the same signature here and here. Okay, any slight change and it will complain that one method is missing. Signature should be same. Okay, now this is a type of inheritance as well. Okay, this is a type of inheritance. Aren't this program and this program both related?
Yes.
Right, this program and this program is bound by certain rules. They both are related. Okay, anytime you find 2 programs linked here, we call it inheritance. Okay. Okay, Honda, iVehicle. There are two classes. These two are related by interface. Okay, these two are related by interface. Now, there is one problem here though. Okay, let's see what that is. Okay, before we go to that, let's do subclass. Okay, the other part of inheritance. This is one type of inheritance. Okay, let's do the subclass now. The classic example of subclass is iPhones. Right now, you have cell phone, the basic phone. What were the basic operations in a phone? The very basic, the very first one.
Making calls, dialing.
Making calls.
Text messages.
Okay, this is the landline version where you can just make calls. Okay. All right, so after this, we got the new generation phones, which is mobile. Okay, now, could you reuse any of the features from your previous generation phones in the mobile system? Okay. Okay, so this is what inheritance is. The mobile class has inherited this method. Okay, that's what inheritance is. The mobile class inherited this method from the parent program, phone. Okay, now here, typically what happens is when you see an iPhone, like iPhone X has several features, right? It has a making call, receiving call, text, browsing, maps. Okay, it has weather. Now here is the question. Every year Apple launches a new version. Do they write everything from the scratch, or they reuse all the software from previous model and add one or two new features to the existing one?
Reuse and add.
Right, they reuse. Okay, so if it took 10 years to go from iPhone 3 to iPhone 10, if you have to rewrite all that software again, don't you need another 10 years for iPhone 11
Yes.
to provide all those features again? Without inheritance, that's how much you need. Okay, today in 2020, if you have like 100 features in iPhone, they took literally 10 years to get here. Okay, now in 2021, if they want to launch a phone with 101 features, technically, if you do not have inheritance, you would need 10 years plus additional time for the new one feature, isn't it?
Yes.
That's what it would be if there was no inheritance. Okay, they took them 10 years to launch a phone which has like hundreds of features. If you want to launch another feature, facial recognition, scanning, just one more feature they added in iPhone X and done. They didn't have to wait for 10 years plus the new feature development time. No, they just did that in 1 year because they didn't have to write the code for the existing features, right? Didn't they just borrow this and spend additional time for the one new feature they want?
Yes.
That's what we will be doing as well in inheritance. Okay, so you start a software with one version. Okay, so they started with a basic phone. They launched a basic phone first. Then they took this functionality and extended with one more feature, text. And now we launch our new product called mobile. After that, they launched iPhone from the basic mobile. What was the one new thing other than text and call?
Camera.
Camera. And this goes on all the way till your today's phone. Okay, you have iPhone 3, and iPhone 3 became iPhone 5. 5 became 10, and so on. Okay, every time all they did was they inherited an existing feature and just extended that. Okay, you had a camera here. Let's say you had browsing here. Okay, then you had facial recognition here. You had scanning. Okay, so what happens is, if mobile is the program, that extended phone, how many methods does it have?
2.
Yes, it inherited one from its parent, and it has one of its own. All put together, how many methods are available for the mobile class?
2.
2,
How about iPhone?
3,
3. Okay, mobile itself had 2. One that it inherited from here and one of its own. Mobile had 2. That plus 1 here becomes 3. So the relation between iPhone and phone is like a grandparent and a child, grandchild. Okay, if this is parent and child, this is grandchild, and this is grandparent. Okay, and this pile up goes all the way till iPhone X. Okay, everyone inherits from its previous class and the previous class and the previous class. Okay, everyone inherits all the way down the chain. Okay, so a more technical word we use here is superclass and subclass. Okay, superclass is a reference to the parent program, and subclass is a reference to the child program. Okay, superclass and subclass. Okay, all right, so let's start with that iPhone program example. All right, so we have a basic iPhone which does make which allows you to make calls, send text, and camera. Okay, what we'll do is after 1 year down the line, we'll launch another phone, an upgrade from iPhone 3 to iPhone 4. Okay, now iPhone 4 launched Apple Maps along with their basic functions. Okay, so let's see. When I create an object, okay, if I create an object of iPhone 4, okay, now technically here, if you notice, how many methods do we have? Just one. When you inherit from iPhone 3, how many did you get?
3 more.
3 more. Okay, so if I say i4 dot, you will see all the methods listed. Okay, I see Apple Map, which is part of iPhone 4. I do see Go camera as well. Is camera method in iPhone 4 class?
No.
No.
It was inherited from iPhone 3. Making call, even though I didn't physically write here, it is still inherited from iPhone 3. So you can basically call all the methods that you have plus all the methods that you inherited. Okay, this is the original method that you had, and these are the inherited methods that you got from iPhone 3. Okay, that's the inheritance. All they had to do was just put a relation here, extends iPhone 3. And this chain goes on as many level as you want. Okay, so here there is a grandparent and grandchild relationship, right? So iPhone 10 is the child of iPhone 4, and iPhone 4 is the child of iPhone 3. Okay, so the relation between iPhone 3 and iPhone 10 is
Grandparent and grandchild.
yes. So this method inheritance goes all the way till the last chain. Okay, everyone will be able to inherit from its immediate generation. Okay, so here in this case, if you create an object of, let's say, iPhone 10, this is the method that you inherited from your grandparent. And this is the method that you inherited from your parent. And this is the method that you have added as a new feature. Okay, this is the actual iPhone 10's new feature. This one was inherited from your parent, and this from your grandparent. You can access every one of them. Okay, so this has multiple benefits. Okay, let's see. What is the one obvious benefit here?
Reuse. You
Of
don't have
having
to do
inheritance?
it from scratch.
Yes. Reusability. Okay, you can reuse all the methods in your program just like that without rewriting. You don't have to write everything from the scratch. Okay, you don't have to rewrite anything that already exists. You can reuse them. Okay. Now there is also, your code also becomes more flexible to new changes. Okay. Now imagine if there was no inheritance, you would have 4 different classes, right? iPhone 3, iPhone 4, iPhone 10. You have all different classes, and there was no inheritance at all. Okay. So technically, what you'll have is a program which will have all the methods duplicated. Okay, you'll have like this. Okay, so you have 2 methods here, 1 method here, no more inheritance. No more inheritance. So here you have duplication in 3 places, right? Making call, making call, making call. Right? So there is all sort of duplications here. Now, tomorrow, let's say we had to make changes to the call functionality in all the iPhones. How many places would you have to make changes now?
Everything, everywhere where we used it.
Everywhere. Okay, someone says now to make a call, we need to use 4G LTE network. Okay, this is the new latest network in 2015, let's say. Okay, in 2015, the latest network was 4G. Until the before that, everyone used to have 3G, 2G, and all that. Okay, so now iPhone is required to make changes to all the iPhone models that are in use in the market. Okay, so as of now, people have several models, right? Does everyone has iPhone X? Do they?
No.
No.
People still use iPhone 6, iPhone 8, iPhone X, iPhone 11, right? People use all sort of iPhone models. So can they make the code change just for iPhone X and not for iPhone 11? They can't. They have to make changes in all the models that are in use right now in the market. So without inheritance, what you would eventually end up doing is you make changes in all the phones that has make call functionality. So this code is not flexible to the new change, right?
Yes.
Okay, flexible to existing features. This code is not suitable for, is not flexible for existing feature. We are making changes in this existing feature in all over the place. Okay, that's not flexible. Now the second thing is adapting to new changes. What if all of a sudden iPhone decides that every iPhone should have weather functionality? This is a new change, adapting to new changes. Okay, what we had was changes to the existing features. Okay, you have to do changes in multiple places. Now the next question is, what if they want to launch a feature like weather? Okay, they want to show you the weather app in all the iPhone models. What do you have to do now? If you have to add a weather functionality, what do you need to do in these 3 programs?
Just add the weather functionality on the parent class.
This is no inheritance. There is no inheritance. So what is the downside? Don't you have to create that, implement that in every single class?
Yes.
So is your code adapting to new changes easily?
No.
No. Is it flexible for any changes in the existing feature?
No.
No.
Are you able to reuse?
No.
No. For all those reasons, inheritance is what comes to your rescue. Okay. You already saw reusability here. Okay. Without writing much code, you inherit everything. Now, this part, flexible to existing features. Okay. Now, if someone asks me to make a call change in make calls, if I do this change, isn't this method inherited by all the classes?
Yes.
So whatever you make changes here, it will be inherited as well. So you don't inherit existing code only. If you make any changes, that will also be inherited. What about new changes, adapting to new changes? I make change in one place. Okay, I didn't make any changes to the subclasses. I go here and I just do this. Do I have access to the new?
Yes.
Did I make any changes to these subclasses?
No.
No. So any new feature you add, you have direct access to them. You don't have to make changes in iPhone 10 or iPhone 4. Any changes you make in an existing feature, you don't have to make any changes to iPhone 10 or iPhone 4. You have readily access to all the new features, to all the changed features, to all the existing features. That's the benefit of inheritance. Does that make sense?
Yes.
All right, so let's think about some practical example. Okay, take the payment example. If you are working on an online website, how do you implement the payment section? Use inheritance to make your life easy. You have payment by credit card, payment by debit card, payment by bitcoins, cryptocurrencies, PayPal. How do you go about writing the code for it? What is the one thing you can reuse in every class?
Payment method.
Payment as in
The superclass.
Mm-hmm.
what do you do in superclass? Okay, when you think about reusability, what you need to picture is, when you think about inheritance, what you need to visualize is, what are the common features in all these different mode of payment? So I don't have to write the same code in all the payment programs. That's what you need to think. What do you do on the payment page? When you check out, what are the things you fill up?
Credit card
Personal information.
Payment details.
Payment details and
Card details.
Address
Credit card.
details.
billing
address. Okay, billing address, shipping address. Now, these are the things that you usually have. You have payment details followed by billing address followed by shipping address. This is what you see no matter what payment you select. Credit card, debit card, cryptocurrencies, PayPal, they all have this. How can you use inheritance to make your life easy? think reusability. What can you reuse in these three categories?
Address.
Address. If you're doing a PayPal address, if you're doing a credit card payment or a debit card payment or cryptocurrency payment, does the address format change?
No.
No.
Aren't address always the same? They have a street address, they have a building number, they have a city, state, zip code. Will that ever change what payment you select?
No, it doesn't.
So can't you reuse that code in all the other classes?
Yes, sir.
So if you have three methods, payment detail, billing address, shipping address, how do you write inheritance program here? Think reusability, whatever we talked about, inheritance and all that. First, create a class. What do you want to name it?
Address.
Just say payment. You have payment and you have two methods, public void billing address public void shipping address. What do you do next?
Now public class pay by debit.
Very good. And
Extend
Extend payment.
yes, extends payment. So you don't have to write the code again on collecting the billing address and shipping address. That code is already available from the parent class. Here you need things like the 16-digit code, expiration date, and security code. Okay, you write that. You write the code for that here. What about credit card payment?
Same.
Public class.
Public class, credit card, extends payment.
extension debit payment.
Okay, it's almost the same format. How about PayPal?
Same format.
Does PayPal has credit card number, expiration date, security
Oh,
code?
no. No, login. ID and password.
Cryptocurrencies. Some wallet ID, crypto wallet ID or something. Do you see the benefit of having inheritance here? Did you have to write the billing and shipping address code in the 4 different classes here?
No.
Think like that. Understanding inheritance is one thing, but you need to also know where you apply. How you apply the inheritance logic. You have to understand that as well. Give another example where you could apply inheritance. Look at some feature which has multiple options. Okay, like payment by this, payment by that. Among them, billing, shipping address is same. We'll keep that in superclass. We'll inherit that. That's the simple logic. Now think about online websites that you have been using for a decade. And imagine what is suitable for inheritance in those cases.
Laptop.
Laptop as in?
Like we can start from PC and then we can end in the laptop. Like first there was a PC, then we had added the monitor with it, and then the USB port with it, and
Yeah, I mean, those technically make sense for everything. Okay, you have a father and the child program, and you have a fan, table fan, and a ceiling fan. Okay, you have a bicycle, and you have a car. Okay, I want something realistic. Okay, you have been using websites, all the things, login, browsing, products, shipping, payment, checkout. I want you to apply there. Facebook, you upload post. It applies everywhere. You go to registration, you have a buyer and a seller, two categories in Amazon. What's the one common thing between a buyer and a seller?
Customer name.
Product.
They all have customer user IDs. They all have a password. They are all customers of Amazon. There are sellers, merchants, and there are buyers like us. They both log into Amazon. They both have to register on Amazon. But what information Amazon collects, isn't that different? For seller, you will have user ID, password as usual, address as usual. Then there will be some information which is unique to a enterprise or a business entity. Maybe their business, some registration ID number that they registered with the government. Do you need that for a customer, regular customer?
No.
You don't. So you take all the common things and put it in the parent class. You have customers and you have employees, two program. Write the inheritance code for that. What are the common things between a customer and an employee?
It's gonna be name, address.
Yes.
Login and password.
Okay. And what is the unique thing about having an employee? What does employee has that a customer doesn't?
Makes money.
Salary.
Salary.
Salary is different. You pay salary for employees. For customer, do you pay salaries? No.
You take
They
one.
have credit card number registered with you. Again, so you start with the first class. What would you name the parent class? A customer and an employee. What is the common thing between them? What can you say they belong to the same, which category do they belong?
Users.
A person.
Person.
So person is your parent class and the child class is either employee or customer. So typically when you're writing a program, that is what you need to pay attention on. Okay. Look for the term is a. Look for the term is a. iPhone is a phone. Is that true?
Yes.
iPhone X is a iPhone.
Yes.
a phone is a iPhone X. Is that true?
No.
No. So that's what is an indication. Okay. If you say iPhone is a phone, it typically in a program translates like this: public class iPhone extends phone. That's how it translates. But phone is a iPhone. This doesn't make sense. Is every single phone in the world an iPhone X?
No.
No. Is every single iPhone X in the world is iPhone?
Yes.
Yes.
Yes. That's true. Okay. That's how you need to understand how the relation transforms. Okay. Car is a transportation. True.
Yes.
Nissan is a car.
True.
Okay. Nissan GTX is a Nissan.
True.
A car is a Toyota.
False.
That's false. Okay. Now that's the reason. That's how you'll understand how to write a class. You can never say public class car extends Toyota. You can never say that. It grammatically doesn't make sense. Car is a Toyota. Does that grammatically make sense to you? Is any car in the world a Toyota? It doesn't make
No.
sense. Nissan is a car makes sense. No matter what Nissan car you have, what Nissan you have, it is a car. We know that. And that tells you that car is a parent class of Nissan. The same example. Employee is a person.
Yes.
Person is a customer. Is every person in the world a customer?
No.
No. It's a simple trick how to understand how two programs are related. Which one will be parent, which one will be child. If you just want to understand that, follow this simple trick. Is a relationship. Okay. Now, extends is the keyword that you apply to connect or inherit from another class. Okay. Now the first rule is you can only inherit from one parent. Okay. Let's see why is that. Now there is a method turn. Okay. And this program says when you call the method turn, it says take left turn. Okay, this method says take a left turn when you call the turn method. And there is a similar method in the second model which says take a right turn. Okay, so you have already seen when you create an object of child class, all the methods that you have in the parent will be inherited. Now, when I create an object of child car, what will it do? Will it take a left turn or a right turn? Because the same method appears in two different parents. What will the child class do?
So do both turn
You can
left
do
and
the
right.
Okay, that's the confusion. Now the child class is confused. Do I inherit parent 1 or parent 2? Technically, you're supposed to inherit everything from parent 1 and parent 2. Okay, so if both of them have different directions, this class is confused. Okay, so to avoid this confusion, what Java did was they totally blocked multiple inheritance. You cannot inherit from more than one class at the same level. Okay, at the same level, you can have inheritance at multiple level. You can have parent and a grandparent and a great grandparent. You can have multiple level, vertical level. Okay, but in horizontal level, you cannot have two programs. You can only inherit from one program at a time. And the reason is this problem. Okay, so this particular issue is famously called as the diamond problem. Okay, because of the shape of it. You know, right, how diamond is shaped? Inverted triangle.
Yes.
Right, so this is called the diamond problem. The diamond problem basically might create a conflict between two parents. Okay, two parents might have conflict on certain features. When that happens, the child class will be confused on which one should I inherit from. To avoid that conflict, that confusion created by the diamond problem, child class cannot inherit from more than one parents. Okay, so here, if iPhone 10 tries to inherit from two programs, iPhone 3 and iPhone 4, you get error. Okay, you cannot have more than one inheritance. Okay, that's the diamond problem. It's a very famous interview question as well, so do remember that. Child class cannot exist without creating a parent object first. Now this is a little tricky, so pay attention. Yeah, so before we go there, it's not that you inherit only methods, you also inherit variables. Okay, okay, so the parent class has a variable a, the subclass has b, and the grandchild has c. Okay, so when I say iPhone 10's object, right, I can access the variable in the iPhone 10. I can also access that in from the parent, and I can also access from the grandparent. Okay, so remember that when you create an object like this, when you create a class like this, you inherit all the methods from parent class and all the variables from the parent class. You do both. Okay, so B and A are the variables from parent classes. Making call is from parent class. Apple map is from parent class. This is from its own class. Okay, so these are the only two which were part of the iPhone 10, the variable C and facial recognition. These variables and these methods were inherited from the parent class. Okay, so you inherit both. Remember that. Now getting back to the object creation, let's see. So this is the constructor. Now, when you create an object, what happens first?
It gives the reference location.
It creates a reference location and
The constructor runs.
constructor. So which constructor runs here?
The
What will it print?
iPhone 10.
iPhone 10. But here is the question. Can a child exist without a parent? No. Right? So if you're creating a child object, can it be done without a parent object is created as well?
No.
No. Okay, whatever is true in the real world, it applies here as well. Okay, a child cannot be created without you creating a parent first. This cannot be created without you create the parent first. So technically what it will print is not just iPhone 10, but look at the order. So who comes first here? Who is the main, the root of all the iPhone programs?
iPhone 3.
iPhone 3. And after iPhone 3, who comes next?
iPhone 4.
And then iPhone 10. So you will see that it was created in the same order. iPhone 3, then iPhone 4, and then iPhone 10. In the same order that the inheritance follows. Okay, even though you created which object?
iPhone 10.
You created iPhone 10. So in order to create iPhone 10, it has to also create its parent and its parent. Okay, so this is how the object creation goes for iPhone 10. Okay, you have iPhone 3. then you have iPhone 4, and you have iPhone 10. Right, so this is what you have, the connection, the variables and constructor, the variables and constructor, variables and constructor. So when you create an object like this, new iPhone 10, the first thing that happens in the memory is
New location.
give a new location, okay, allocate some space, allocate some memory in a location. Now, what happens next?
Store the
Which
instance
variable
variable.
you create here?
Variable.
Variables.
Tell me the specific name.
Instance
Instance
variable.
variable.
Instance variable. You have to create instance variable. So when you go to iPhone 10 to look at all the instance variable, what you realize is this phone is a child of which class?
iPhone 4.
iPhone 4. So before we create any variable here, it has to go to the iPhone 4 and see what we have here. Okay. Now in iPhone 4, before we create here, does this also inherit from someone else?
Yes.
Yeah.
iPhone 3.
iPhone 3. So go to iPhone 3 and check if this has any dependency or anyone in the inheritance line anymore. Does it have anyone?
No.
No.
No. The first variable you create is
A.
A10. Now that this instance variable has been created, it goes back to iPhone 4. What are the instance variables here?
B. 10.
Now you go to iPhone 10, which is the whole thing started, right? Now you create this instance variable. That is the order of instance variable creation. Okay. All right. So far we are done with this. Okay. We are done with the new operator. After new operator, what happens next?
We assign it to IX, the value 111.
No, that is just the new operator job. Okay, whatever we did, it was just new operator job. What comes after new?
We make a constructor.
We call the constructor, iPhone 10 constructor. The control goes here, but this is where the compiler sneaks in again. Here, when you write a code like this, every constructor in a subclass will have this word written without your knowledge. Super. Okay, this keyword is used to refer another constructor in the same class. Super is used to refer
Superclass.
yes. Super is used to refer the constructor in the parent class. Who is the parent of iPhone 10?
iPhone 4.
So super refers to the parent class constructor. Okay, even you didn't write the super line here. Okay, even though you didn't write it, compiler will add this line for you. And it did the same for here as well. Even though you didn't write it explicitly, compiler will write that code for you. Before you do anything in this constructor, go and check what you have in the super class first. That's what this line means. Okay, so compiler is trying to make sure before you do anything with this program, a child cannot exist without parent. So go and look in the parent class first. That's what this line does. Super. Okay, by encountering this line, it goes to your super constructor here. And when you get inside, what do you see the first line?
Super.
Super. So it goes back here. And that's why it printed iPhone 3 first. When you're done with this constructor, where do you go back?
iPhone 4, line number 6.
Here. So it prints iPhone 4. After it prints iPhone 4, where do you go back?
To iPhone 10.
Here. Okay, so few things to notice. Use the keyword extend to inherit from other class. Okay, that's the first thing we do. Okay, we inherit. Second, the subclass will inherit all the variables and methods. Okay, there are some circumstances where you cannot inherit variables and methods. We will know more about that in access privileges. But for now, just understand that you will inherit variables and methods. Okay, but we'll see what are those exclusive cases where you cannot inherit in the access privilege chapter. Okay, so you inherit all the variables and methods. Third, constructors are invoked in the inheritance order. Okay, if you call the constructor of iPhone 10, before you do anything here, okay, before you do any execution here, the control goes to iPhone 4, its parents. In the inheritance chain, it goes to the parent. And before you do anything here, the control goes to iPhone 3. Okay, so the constructors are called in the inheritance line. Whatever inheritance line you have, in that same order, constructor is called. And how does it happen? The compiler will add this line for you without your knowledge. The super parenthesis, this line is added without your knowledge. And because of that reason, even though the constructor of iPhone 10 is called, the control goes to your super first, and then super first. Prints iPhone 3, prints iPhone 4, and then prints iPhone 10. Okay. Constructors are invoked in the inheritance order because super statement is added as the first line. Okay, because super constructor statement is added as the very first line. Remember that. Now, everything is working fine. What happens if I change this constructor to take integer parameter?
Then we have to create the super with
You get an
integer
error.
parameter.
Why do we have an error here? when I added int a,
We need a parameterized constructor.
so if you don't write anything, what does the compiler add here and here?
Super.
It adds super. It adds super. Okay. And what does super means?
Calling the parent class constructor.
Yes. So we are calling a parent class constructor, and what is the parameter?
We don't have parameter passed.
Nothing.
No parameter. So in the parent class of iPhone 4, which is iPhone 3, do we have a constructor that has no parameters?
No.
And that's why the error. Okay. When you see this error like this, what it means, you might not understand why you're getting this error. The reason is, when you write a program like this, the compiler will add this statement. If you don't write super yourself, it will add this statement for you. And when it does that, it will realize that the parent class does not have a constructor with no parameter. That's why that error. Okay, this error comes in like this. So now, what if you add a constructor which takes no parameter? When I save this error will go away. It went away because when compiler added this line for you, it was able to satisfy this need, a constructor without parameter. Okay. Now you know all about this and super. Guess the output. When I create an object of iPhone 10, Aja, what's the first line it will print?
I'm sorry. In iPhone 3 int.
iPhone 3 int. Okay. Anyone else has any other ideas? Ashmita?
Since it's extended, will it go to the very
like it will go back to the iPhone 3, and since that is also been inherited, so oh no, not the iPhone 3. Will it go to the iPhone 3, the first one, the parent class?
Yes, from iPhone 10 to iPhone 4 to iPhone 3. That's the usual case. You know what this operator does, right?
Yes,
So what does this do?
it communicate.
Yes.
Does that print both in iPhone 3 int and in iPhone 3?
All right, let's go step by step. Ashmita, here, when I call iPhone 10 constructor, where do you go first? Which line number?
I would say that would go to the line number 9.
9 in which class?
In iPhone 3.
No, don't go to the end.
Oh, I mean the iPhone 4.
In iPhone 4, okay, from this program, when I say iPhone 10, don't tell me the end result, tell me the next step immediately. From here, where do you go?
It will go back to the line number 10 of the iPhone 4.
Okay. This is the iPhone 10 constructor, so you go here. This is the iPhone 10 constructor call, so you go here. Line number 4, isn't it?
Yes.
Bhakta,
Yes, sir.
what happens after you come to this line? What's next?
Mm,
What's the very first line in the constructor?
so iPhone 10.
Whoa, why are
Okay.
you angry
After that, what line do you have?
Remember, it's stop blocking my way.
Just read the program. What's the line number 5?
Super.
Now in that line super, where do you go from there?
iPhone 4 constructor.
Okay, one at a time.
Then it goes to
Means where do you go?
iPhone 4 extend, iPhone 3, like line number
Okay.
4.
This line means what? Super.
Yeah. Uh-oh.
It's the constructor in parent class.
Yes, very good. It's the constructor in the parent class. Super bracket means constructor in the parent class. So who is the parent class of iPhone 10?
It's iPhone 4.
Yes. So it is going to the constructor of iPhone 4. That's how you phrase it.
Oh, okay, yes.
Okay. Now,
Yes.
there are 2 constructors in iPhone 4. Which constructor will it go to?
It goes to
Line number?
At least I just say
Line number 4.
Guys, one at a time. I'll get to you.
to line number 4.
And why does it go here?
Because this is the parent class for iPhone 10 extend. iPhone 10.
Is that the only reason? There are 2 constructors, 1 and 2. Super, you said, means it goes to iPhone 4, the parent class constructor, right?
Yes.
Now there are 2 constructors in the parent class. So I'm asking which line will it go and why?
It should go to the main class. That's why it goes
What?
to line 4.
Why does it go here and not here?
Because line 4 is the constructor and line number 8 is the method.
How do you think this is a method?
Oh, this is. Oh,
Why is
it's
that
not
a method?
method. Oh, it's not a method. My bad. In line 4, we don't have pass the like it's empty constructor.
That's what you need to focus on.
Yeah.
This is an empty constructor, and here we are calling parent empty constructor. Remember that?
Yes.
Okay. That's the answer. You go here because the parent empty parameter constructor is what we are calling. And there is only one line here which has an empty parameter constructor. All right, Bikash, what happens next? After you come here, what is this line?
It's calling another constructor on the same class, the iPhone 4 int A.
Int A. This means you're referring to another constructor in the same class. Okay, so super means you're referring to a constructor of parent class, whereas this means you're referring to the constructor of the same class. It goes here because you're passing 10, which is an integer. And here is a constructor that takes integer. Very good. All right, so Chavani, what next?
Yes. So now it's going to go to the line number 9, super. That
And what
it's going
is
to
here?
and then it's going to go back to the line number 4 in the iPhone 3 class. Oh no, it's going to go to line number 7 in the iPhone 3 class.
Exactly. Okay.
Yeah.
This is referring to a constructor, parent constructor, which has no parameter. Parent constructor, which has no parameter. So parent is iPhone 3. In iPhone 3, look for a constructor with no parameter. Right here. All right. Shrestha?
Yes, sir.
What next?
Then it's calling the same constructor by this, so it will go to line number 4, public iPhone 3 int A.
Very good. So here, when you say this, you're referring to a constructor in the same class, which can take integer. So right here, we have another constructor that takes integer. DK, what next?
Yes, sir.
What's next?
It will print iPhone 3 int.
Okay, so that's the very first line that it will print, iPhone 3 int. All right, DK, after it prints, where does it go next?
So can you remove that thing? It will go to the iPhone same down. It will go to the system, the audio number 9 of iPhone 3 class.
Very good. Okay, it goes back from whoever called it. This is the line where iPhone 3 int was called. So after you're done with that constructor, you go back and continue where you stopped. All right, so Rajan, what next? After printing in iPhone 3, where will it go back?
It will go back. It will go back to the iPhone line number 8 of the iPhone 4 class.
So will it go here? Is that the accurate line?
No, it will go back to the line number 4.
Here?
Yeah.
Now, iPhone 3 is a parent class. iPhone 4 is the subclass. When did you transition from here to here? Which line sends the control to the parent constructor?
9.
Line number 9. This is where you gave the control to the parent. So when the parent is done, which line would you go back to?
Line number 9.
So when you're done with this line, where do you go back? Go to
10 int iPhone. It will print in iPhone 4 int.
So that's what it will print first. Okay. You don't go to iPhone 4 line. You don't go to line number 8. It will come here because this is the line super which gave control to iPhone 3. So the order of printing is iPhone 3 int, iPhone 3, and then iPhone 4
int.
All right, Milan, where do you go next? Who called iPhone 4 int parameter? That's where the control is.
Line number 5 of the iPhone 4.
Yes, this is where we called the constructor that takes int. So after you're done with this line, it will print
In iPhone 4.
yes. Subhaj, where do you go after this? Sadiq,
Yes, sir.
where do you go after this?
After printing the in iPhone 4, it go to the line number 6 of iPhone 10.
That's it. Okay, so it will print 3 int iPhone 3, 4 int, 4, and then 10. Three int 3, 4 int 4, and 10. Okay. All right, guys. So we'll stop here. Okay. So tomorrow we'll do the remaining chapters in the interface, remaining topics in the interface. We will do this when we get to polymorphism. We'll do this when we get to the final and static chapter. And we will do this when we get to access privilege. Okay. There is a follow-up on these three in a separate dedicated chapter. Polymorphism chapter, access privilege chapter, and static and final chapter. Okay, so these will cover when we get there. Okay, so now you know how the super keyword is used. You know how the inheritance works. You know how objects are created. You know the basics of interface, why we need interface. And you know how to implement an interface. Okay, so tomorrow we'll learn something about a new feature that they added in Java 1.8. Okay, there is a new feature that they added in Java 1.8 that allows you to create methods in the interface. Before that, you could not implement anything in interface.